Okay. Are you ready? We start the content for today. Brian,
Yes,
how are you?
I'm good.
Haujaonekana for long.
We Nico nearly joined last Thursday, I think.
Oh, that's why your name is not familiar. So, for this cohort, we are just about 6 to 7 there. So, tunang'ang'ana tu kidogo kidogo. Sawa sawa. But
By last week to submit my project, my chain has some issues.
yes, what? When will you submit it?
Probably if it's the issues will be sorted today, I'll submit it tomorrow.
Okay. Just make sure you submit as early as possible so that you may not have two projects. Sababu on Thursday we are giving another one for this week. So none of the workload, so better you subtract the workload as early as possible. Yeah. So yes, I think today we can just dive in on what we are supposed to cover. So. Yes. So let me open the notes. And today, okay, let me check. Have you downloaded the notes?
Yes.
Okay. Okay, let's now continue. So today we are going to do the econometrics, and you'll understand how we do econometrics using STATA. So. Let me share with you my screen first before we proceed. So make sure you understand concepts. Then you try to combine those theories with ABCD there, yeah. And in econometrics, for example, I'm sure you have some basics of terms that are used in econometrics, and those are the ones that you will be using here today. So what is an econometric? What is an econometric? Econometrics is a branch of economics that will combine mathematical and statistical methods with economic theories to analyze and quantify economic relationship, test economic hypotheses, and make predictions or forecasts about economic phenomena. So it involves the application of statistical techniques. So you can see how statistics is related with the econometrics. Yeah. So we use statistical techniques to the economic data. Are we okay? Are we together? So after using this statistical technique to the economic data, now we can come up with estimate and make decisions based on those output that we get after the analysis. So yes, that is it. So the main objective of econometrics is just to provide an empirical evidence and insight into economic phenomena by using data and statistical models. So basically what we are doing here today, we are trying to combine statistical techniques using STATA. We apply statistical techniques on economic data using STATA. So are we together? That's what we mean by that point. And economic analysis will typically involve the following steps. The first step is to formulate an economic theory or hypothesis. The way we introduce hypothesis in projects, the same way we introduce hypothesis in our daily project that we solve outside here. I'm sure you understand what I mean. And after introducing the hypothesis, it's upon you now, either you are in data to reject or fail to reject that hypothesis. Then at the end of it all, you will be able to do a conclusion, to do a proper conclusion based on that analysis. Based on that analysis. So this is the first thing. So this step will involve developing a theoretical framework or hypothesis about the relationship between different economic variables. So the second thing, you collect data, relevant data on the variable of interest are collected from various sources such as government agencies, all those things. But it depends with the type of economic data that you are handling. Number 3 is specifying the econometric model, and an econometric model is just a mathematical representation of the hypothesis, of the hypothesized relationship between a variable. So it will specify the functional form and the nature of the relationship to be estimated. Which other? From that, you estimate the model itself. Now you estimate the model, that is, use statistical techniques to estimate the parameters of the econometric model using the available data. So you can do estimations methods. You can use estimation methods, for example, the OLS, the ordinary least square method, MLE, that is maximum likelihood estimation, or the IV estimation. You remember the I think you are supposed to go through the IV today, among others. So from that point now, you evaluate and test your model. This estimated model is evaluated and tested to determine if its statistical significance and goodness of fit. From there, you can have various diagnostic tests. Various diagnostic tests. They are always there to accompany statistical theories, specifically on assumptions that come with some data, with some test, with some test or statistical methods. So for example, you remember in time series, the diagnostic test that you do is estimating or evaluating whether your data is stationary, whether there is a correlation between lags. All those things are diagnostic tests. So from there you interpret your result. That is it. So we have subtopics that we are supposed to cover today, and we will not do all of them because we didn't some last week. So regression analysis will take the same format that we did last week, but now if you have econometric data, then you can do regression analysis on now econometrics. So what is changing is just the source of data, so we will not do this one here. But I remember we have to do the instrumental variable analysis and this other part, then non-parametric and semi-parametric models. The parametric and semi-parametric models. And the first analysis that we are going to perform here is the IV analysis. Let me open my STATA. The IV analysis, instrumental variable analysis. Okay, who has ever come across the word instrumental variable analysis, the IV? Nani ameipatana na hiyo maneno anywhere, either classwork or outside? Hakuna? Okay, that's a new knowledge, yeah? So make sure after the class you understand. You can now teach someone or introduce someone to the IV analysis. You can introduce someone to the IV analysis. So let's dive on IV analysis. Let's dive on the IV analysis. What is an instrumental variable analysis? So the IV analysis, or the instrumental variable analysis, IV itself, the instrumental variable, is a variable used in econometrics to address heterogeneity, which also arises when there is correlation between a variable of interest and error term in a regression model. So IV are chosen based on their ability to isolate the variation in the endogenous variable that is unrelated to the error term. So IVs are required to satisfy two main conditions, that is relevance and exogeneity. So relevance means that the IV must be correlated to the endogenous variable. Yes, so these are just some theories. These are econometric theories, and this ensures that the IV provides useful information about the variation in the endogenous variable. Exogeneity now refers to the IV being uncorrelated with the error term. Yeah, so this condition ensures that the IV does not suffer from the same endogeneity problems. So the use of instrumental variable is a valuable technique in econometrics because it will allow the researchers to overcome endogeneity and obtain what? And obtain the consistent estimate of causal effects. So in IV analysis, the IV analysis is particularly useful when conducting observational studies where random assignment or controlled experiments are not feasible. By carefully selecting the and validating instrumental variables, researchers can mitigate the biases that may arise from endogeneity, leading to more reliable and accurate econometric analysis. So I'm not an economist by profession, but I understand this method. So it's upon you now to go and research more on what we mean by the IV, because you may never come across the IV analysis, and introducing you to a new thing in just 1 hour, it does not mean that you are perfect, or you are genius. You will get everything. So it's upon you to go and research. When do we apply these IV analysis, the scenarios or the examples where IV analysis is of importance? So yes, that is it. So let's now try to define some ones that are related to the IV, and from there we perform the IV analysis using our what? Using our software. We have the endogenous variable. This is a variable in statistical model that is changed or determined by its relationship with other variables within the model. Sawa. Yes. Another one is the instrumental variable. This is a variable used in statistical and econometric analysis to address the problem of endogeneity or omitted variable bias. Yeah. So it serves as a substitute for an endogenous explanatory variable by satisfying two key conditions: relevance and exogeneity. So the instrumental variable should be correlated with the endogenous variable of interest. So that is it. Now I want us to dive on our the kind of data that we are going to use. We are going to use the instant data sets that we have in STATA. Before we proceed, how do we access the inbuilt data sets in STATA? Nataka kusikia kutoka kwenyu. How do we access such data? Joy Murengi. Nataka kupata directions from you. How do we access the data that comes with this data? Mr. Joseph. Frinda.
Yes, Bernard.
Yes, how do we access the pre-installed? Do we say pre-installed or the install? The data that comes with STATA. That's what I mean.
Wow. Hapo niko nje kidogo.
Kuna last week
umejua nimemiss classes sana.
Ndio maana nakuuliza hivyo.
Nilikuwa na a problem, but I'm back.
Tutajikaza tu, si ndio? Eh,
Actually, I was trying to go through the nini. The problem ni during the day unakuwa very busy kwa job, so
yeah.
I'll go through them during the night alafu nijaribu catch up.
Oh, no problem. Huh?
Eh,
Okay. Frida, Frida, how do we access those data sets?
I think I was also having the same problem with Joseph.
Uh-huh.
Yeah, so
But
I was not able to attend most of the classes and I was having problem downloading the content.
okay,
Yeah.
Mr. John. But Frida, but you know there are some data sets that you can access. It's just for your revision when you install that software, STATA. So when you install STATA comes with some data sets for practice. That's what you mean. Eh? So that's the kind of data that I want us to use for demonstrating here. Sawa sawa. Are we together?
Yes.
Yes, that is it. So I want you to be very keen when you want to access the data that is already in STATA. You remember last week during our introduction, we said that here is where the variables of your data set is displayed. Yeah, so it means right now my STATA memory has no any data set that is present in it. Yeah, so remember you can either import from Excel that is outside the STATA memory, or you can use the installed datasets through this part. That's this example dataset. When you click OK, you will have this window popping out. Then you can click on example dataset installed with STATA. Sawa sawa. So you just click on this part and we have dataset here. Sawa sawa. And we have the dataset there. For example, suppose you want to use the sensors. When you just click use, something will happen here and here. So just click on use sensors. For example, I think you can see what has happened. We have so many variables here and we have a command for using what? For using for displaying this dataset. So the command is actually the system use, and this part here, sys use, then you display the name of the datasets. Then from there you can have that kind of dataset. So I didn't find okay, these are population of a certain population of state. I think this is the USA, if I'm not wrong. So Alabama, Alaska, Arizona, all those things. We have state, these are regions. We have population. Population 5, population 7. Yeah. Okay, we have divorce. Divorce, we have marriage, we have death, all these things. So we want to demonstrate now how to come up with regression analysis that uses the IV technique or the instrumental variable technique. Let's see if we have any other data that is so clear for regression analysis in that part. So I can clear my memory. So just write clear, and yes, let's see which data, the type of data that we can use there. Click on education internet GDP, use this one. Let's see whether we have something important there. We don't have. Okay, let's just demonstrate using the census. Let's use the census dataset. So let's use it. System use census. Okay, Mr. Joseph, are we clear up to that point? How we load the already installed dataset in STATA?
We go to data, then import.
We go to file, then go to example dataset.
Okay.
After that, after clicking that, this window will pop out. Yes. Then from there, click example dataset. Click this one.
Installed with STATA.
Yes. So from there you can see you have a lot of datasets here. Yeah. So from there we are going to use the census. Census we have after cancer here, right?
Yes, I get it.
Just click use.
Yeah.
Okay, click use. Kuna hizi vitu zinakuja hapa, these variables will be here now.
State, region, population.
Yes. So for
Yeah.
for you to get a view of those data sets, you can click this part here for data head data. Or you can just type hapo kwa command browse. Browse. Then click enter. So you can see we have these variables now arranged in this format, and we have the data. You can see the data inside. Now we want to run regression analysis that uses instrumental variable technique using any of these columns. Yes, so from that point we can see how we explain the output and interpret it for economical use or any other use.
So what is the main what is the main use of the instrumental analysis?
The
Where
main
do we use it?
The main use of
Instrumental analysis.
the IV.
Yeah.
Okay. Have you ever heard of that name again?
No.
Because it's like okay, I'm not discouraging you, but imagine mtu anakuuliza what do we use, why do we use regression analysis, or what is regression analysis? Ungeanzia wapi?
Regression, at least niko na idea, nilifanya campus kidogo. So naweza kuwa na idea hiyo, nimeisikia, lakini hii instrumental analysis ndio bado.
Okay, sasa tutakuja kuingia mbroni kidogo ili uelewe what we mean by instrumental variable analysis. Sawa sawa.
Oh, okay, sawa.
So I'm just trying to explain again using
How to analyze.
Yes, I will just show you how to analyze the IV, then come up with the analysis and interpret, just a normal interpretation. So yes, sawa sawa.
My query is was just to know when do we use it? Tunatumianga wakati gani maybe?
Okay, just a minute. When do we use the IV analysis?
Yeah.
Let me open that file. Okay. Okay, should we answer the question or we perform? Then you understand the syntax. Then we describe or we
Either can do.
Either can do, Cinder.
Yeah.
Okay, let's dive in on this part. Okay, I want you go back to this STATA menu. This the main window for STATA. So the main window for STATA, and I want you to see here. You just click on statistics. Are we together? Let me close some of these windows here. I want you to click on statistics, generalized linear model, and generalized linear models, that is GLM, and click OK. So from this part, I think I documented something wrong here, if I'm not sure. Just a minute. Oh yeah, actually I documented something wrong somewhere. We don't go to the generalized linear model. We go to the endogenous covariate. So after endogenous covariate, we go to the single equation instrumental variable regression. Then from there, click that part and click your variables. That is the independent variable. Then from there you can have the endogenous variable and instrumental variable, the type of variables that we were talking about here. So So and from that part, from this part here, let's see, I think what I documented is a scenario analysis and interpretation. Yes, so actually you come up with these two. You can have endogenous variable in your model or have only instrumental variable. It's possible, yeah. But now here you have to select. For example, suppose we have we want to have population as our dependent variable, and for independent variable we have the death rate. Now we want to see how population is which is affecting the other. Which one should be independent? The one that does not change is actually what? I want to hear from you. Which is dependent between population and death? Which one depends on the other?
Population.
Population is independent, isn't it?
Yeah.
Population is independent. So let's introduce the endogenous variables, and let's introduce, for example, these are the type of populations that they were listing here, and see what will happen in our model. Remember the endogenous, just remember the definition of the endogenous variable from this part here. This is a variable in statistical model that is changed or determined by its relationship with other variables within the model. So I documented something that is not related to the data that you are using. So we are trying to come up with a new model. So then you can use the definitions that are documented there to come up with the conclusions for the same. And let's have population 18 as our instrumental variable, and keep this. Yes, these are to change. Yes. So from this now, I want you to click OK. I want you to click OK. And what we have is the IV regression model. And imagine how these things is performed only by this command. So even if you don't know how to use the graphical user interface, you can as well use this command. So for example, when that command is on that command window, you just click enter, and you get this result, and you get this result. So now I want you, up to this point, I'm sure you can interpret this model. Cynthia, you can interpret this model because this is just a regression model, Cynthia. But now we have introduced some factors. That is, we have introduced population 15 and population 18. And check this part here. This is population number, is it 15 or 5? Let me see. population 5, and the other one is this one here, 18B. Yes, we have used this part and this part here, those two. So to come up with to interfere with the regression analysis on this part. So this is an IV regression model, and actually you can have it means if we put in consideration those two the two parts on population 5 and 8 on this model alone, I want you to check the accuracy of the R squared when we have the IV variables and when we don't have the IV variables, and when we don't have the IV variables. Let's see. Go to the linear regression and have population and death. Population here, then we have one death here on the other part. So I want you to tell me what is the difference between this normal regression analysis, the R squared, the points that are explained by our model here, and this one here. Which one is more accurate? Is it the IV or normal regression analysis? Which is more accurate? Remember, R squared here account for 94.45% of the data, but the one with the IV account for 96.68 point in our data. Now, the main question is, when do we use IV? When do we use IV? Who has an idea? Who can tell us when do we use IV? Okay, Mr. Joseph and the others. IV, or the instrumental variable analysis, is used in a situation, I wanted to get the point correctly, is used in situations where there is a concern about endogeneity or confounding factors affecting the relationship between the independent and dependent variables. So it is commonly employed in these parts of econometrics and other fields when conducting the causal inference or estimating the causal effects. So I want to tell you all just a scenario when IV analysis may be appropriate. So I want to tell you the scenario when the IV is appropriate. Number one, you can have an experimental studies in situation where conducting something like randomized controlled trials is not feasible or ethical. So the research often may rely on observational data. So, however, these observational data can be susceptible, to confounding variables. So instrumental variable analysis can help to mitigate these concerns by using an instrumental variable to address the endogeneity and establish a causal relationship. That is one scenario. So the second scenario, when we can use the IV analysis, is on treatment effect estimation. When studying, for example, when studying the effect of a specific treatment or interventions, instrumental variable analysis can be used to estimate the causal effect by addressing the potential biases due to some things like unobservable variables. Yeah. Yes. So basically the IV is used in scenarios where you want to deal with endogeneity data. So, and the endogeneity occurs when the independent variable is correlated with the error term in regression analysis. That's what we mean by endogeneity as far as this topic is concerned. And what happens when independent variables is correlated with the error term in regression model? It will lead automatically to biased estimates. So the IV analysis can address the endogeneity concerns by using the instrumental variable that is correlated with the independent variable but not affected by the error term. Yeah, those are some of situations when IV analysis can be used. So, Mr. Joseph, are we okay? Are we on the same boat?
Okay.
Okay, so you can just search on more situations where the IV analysis can be used. So because there's something that is new, so you have to do more research and be familiar with those terms. Be familiar with those terms. So I want, as we have a look on the sample output that are documented here and understand how we interpret the IV analysis. So this given output represents the instrumental variable analysis on two-stage model with a dependent variable open and two explanatory variables, low and high. So the instrumental variable used is low. Yes, this is our instrument variable, and the instrument employed is high and close. So these are just variable names that are used here, and I think the data that I was using was from somewhere in education, but I'm not specific with the source of that data set. So how do we interpret this coefficient? How do we interpret the coefficient and the standard error? So the coefficient estimate for low, you can see here, is negative 0.7419331 with a standard error of 0.19282424. So these are just that one unit increase in low will lead to decrease of approximate this part on the open variable, just the way we interpret other regression models. So that's the same technique that we are using here. And you can see, or you can conclude the statistical effectiveness of these variables on open using the p-values. You can see almost all of the p-values are less than 0.005, the critical value. So we can say this part here, or these variables and effects on the open. So okay, just a minute. I'm receiving a very serious call here. It might be an opportunity somewhere, so just a minute. So that is how we just interpret this part. That's how we interpret these parts. Okay. The coefficient estimate for high is 1.745804. This part here. With that standard error, yes, blah blah blah. So you just interpret the normal way we interpret. I want as we go on the wild chi-square test statistic that we have here, and the p-value associated with it is 0.00, indicating that the overall model is statistically what? Significant. Yeah. So the R-squared value of this part suggests that approximately 97.36%. We are talking of this part. Let me check. The R squared. We are talking of R squared. So I think this was just kuandika vibaya. So this was a writing error. It was supposed to be 0.96. Is it this one? Okay, let me check. Oh yeah, I think it's okay. It's this one. This is 97.36%. So 97.36% of the variation in open variable can be explained by the model. Yeah, so we can actually say this is a reliable model because it's defining almost all the points. So the RMSE, the root mean square error, is 14, representing the average difference between the observed open value and the value predicted by the model. So in summary, this model employs the IV to address endogeneity issue and provide estimate of the relationship between open and the variable low and high. So the results suggest that both low and high have statistically significant effects on the open. So yes, that is it. So the other part is on non-parametric models, and others are parametrics. not parametrics. We are supposed to deal with non-parametric and semi-parametrics. So we have non-parametric models here. When we talk of non-parametric models, you understand that these are models that does not necessarily require your data to follow a specific distribution model. Yeah, and non-parametric models will assume data distribution cannot be defined in terms of definite set of parameters. So we have just some few, and remember, you can come up with yours. So you can define a model isn't it, from experiment. That's how some of the distribution models that we use nowadays were discovered. They were just discovered from experimental data. Yeah, so we have some examples of non-parametric models here. We have the Spearman's rank correlation. You remember last week when I was saying that the opposite of regression analysis. Remember, regression analysis is parametric model, so you can use non-parametric that is Spearman's rank correlation. We have the Wilcoxon sign rank test. We have the Mann-Whitney U-test. We have the equality of median. We have the Kruskal-Wallis, Kolmogorov-Smirnov tests, and chi-square tests for association. So I just sampled some. Then from there you can just go ahead and look for others that I didn't document here. We can start with the Spearman's rank correlation, and using STATA, you will notice that you can get the output, or you can get these non-parametric models in different parts. Yeah, you can get them either on non-parametric analysis and test of hypothesis, or you can get them on summary tables and tests. So yes, that is it. So we will just use that part to analyze those things. So let's do the Spearman's rank correlation. So Spearman's rank correlation, you click on statistics, and you click on non-parametric analysis, and you click on test of hypothesis. From there you go to the Spearman's rank correlation. You go to the Spearman's rank correlation. So you just click OK, and from there you can either specify the number of variables that you want to be analyzed using that method, or you can just leave blank. You can just leave it blank for all variables in the data memory to be included, and the data to be included here are the only ones in numeric format. So yes, so for example, I can leave this space empty, and from there you can decide to adjust, to do an adjustment on the significance level and get your output. For example, with the one significance level, you just click, you just mark this box and click OK. For right, let's see. So this is the matrix. This is the correlation matrix. The correlation between region and region is 1. That's why we have an identity matrix here with the ones hapa katikati, then we have these are the values na huku. Sawa. Yes. So for 5% significance level, you just click on this part here, test of hypothesis, Spearman's rank correlation, and get that part there. Then you have your what? You have your correlation matrix here. You have your correlation. Remember, the most used method, not method, the frequently used is 95% confidence level or 0.05. That's the most hiyo ndio inatumika hata kwa the project. Yes, the statistically accepted alpha is that of 0.05. That of 0.05. So yes. So I'm sure all of you can tell what's the correlation between population. For example, what's the correlation between population and divorce is this part here. Or how do we interpret correlation of 0.9? These are very strong correlations. It's almost 1. It is almost 1, and so we can actually at this point we can say the correlation of 0.9 is a very positive. We can say in divorce is positively associated with the populations. Yeah, so those are just some parts that you have to know concerning the Spearmans. That's how we do the Spearman. Yes, so the other one we can check on the Wilcoxon signed rank test. So the Wilcoxon signed rank test is a non-parametric statistical hypothesis test. In Wilcoxon signed rank test, the statistical hypothesis test used either to test the location of a population based on a sample of data. For example, you can say this data A is the same as data B, you see, but now you can come up with test to test that. And now that is the Wilcoxon signed rank test here. So you just click on summarize, non-parametric and Wilcoxon. So for example, for this part here, you can see, you will notice that we can access that Wilcoxon signed rank test in more than one tabs. Check summarize tables and test, then non-parametric test of hypothesis. We have Wilcoxon signed rank test, this one here, or you can get the same from this part here, the non-parametric analysis test of hypothesis. Yes, you can see we have them here. Wilcoxon matched pair sign rank test. So. And we also have Spearman's rank correlation even here. So no matter the tab that you will use, you will get the same output. So for example, let's run that command here, Wilcoxon. From there, you can specify just the two groups to see whether they are related. For example, let's see group 5, and for expression here, you click on create. I want it to begin. You click on create, and on this part here, you click functions, variables. You click on variables. From variables now, you can double click one variable that you want to include in your analysis. Let's say, for example, you want to include the population variable. You just double click mpaka uone imekuja in this dialog box up here. Yeah, so double click that one, uone imekuja at that point, then you just click OK. So from there, click OK. What are you getting there? We are getting, are we together? Nimeongea sana. Are we following? Unaweza kuwa umepotea, ama mimi nikuwa naongea tu na nilipotea kwa network na sijui.
Yes, tunakupata.
Okay. Now, we want to, this is the output of Wilcoxon signed rank test, and we want now to interpret. Are we together? We want to interpret this part here. Inakuja mpaka huko. Now, this is the sample that's documented here. This is the sample. You can see it. You can see the p-value here. What is the p-value? Let me zoom. The p, the probability greater than z or greater than test statistics is 0.00. What does that mean? So we use this as our p-value here, right? So how do we interpret? So the Wilcoxon signed rank test was conducted to assess the difference between high and close. So these are just variables like the ones that we have demonstrated with. Yeah, so for ours it would be population 5 and population, and the test was performed in a sample of subdivision of 248 of subdivisions. You can get that part from here, this one of subdivisions, this one here. So that is the observations, 248. And for our case, we have how many? We have 50 observations, right? Yes, we have 50 observations. And the test result shows that the sum of rank of correlation between achana na hizi, nataka tukuja hapa kwa the null hypothesis. H0 states that there is no difference between group 1 and group 2 values. So the test statistic Z was calculated to be 13.64. This Z here, 13.64, 0.64. And for our case, what is the value of z? The value of z is negative 6.154. So 154. So how do we get the final conclusions based on the p-value? And the p-value associated with the test statistic was found to be very small. That is, p is less than 0.0001. So based on the results, we can reject the null hypothesis and conclude that indeed there is a significant difference between I and close values in the dataset. Remember the edge or the null hypothesis equate the two populations, or assume that population A is equal to population B. Sawa. Population A is equal to population B. But we either reject or fail to reject based on the p value. Okay, what is the I think I documented something wrong here. Check here. Our p is 0.0000. So it yeah. Let me check. Are we supposed to reject or fail to reject this hypothesis? I think here we were supposed to fail to reject the hypothesis, because the p-value should be, we can reject only when p-value is greater than 0.05, yeah. Yes, so I think for this one here, we are not supposed to reject this hypothesis. We always reject if p is greater than the significance level, or p is greater than alpha. So yeah, I think you can correct that one later. So yes. So the other one for Kolmogov's mean of test is used to determine whether two distributions differ. And remember, anything that we do in STATA, any output that we get is accompanied by the command. So check like this one here. This is the command for sign rank population blah 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 is equal to this. So sign rank here, for our case, this is a function. This is a function in STATA that is used to perform this particular test. So are we together? Yes. So sign rank, this one, then you just click enter and get your output, and get your output, which is the remaining part is the Kolmogorov. Yes, so the remaining part is the Kolmogorov-Smirnov test. So how do you assess the test? You just click on statistics, summary statistics, non-parametric test, and we have one-way sample and two-way. It depends with the type of sample that you have, you can perform one and perform the other. So you can select any population here. From there you create one, create from variable. You just double click any of them, then click, oh no, I haven't. Double click until ikuje kwa this dialog box. Click OK and click OK. Then from there you get your what? You get your output. You get your output. So yes. How do we interpret that one? Interpretation of that one. I want, as we have a view, just look on this pattern documented here is just an output. So the test result revealed a significant discrepancy between the empirical and theoretical distribution, with the maximum absolute difference in D of -9 point, this one here. So and these are the one nataka tukuja mpaka kwa this part. Let me check here. So the p-value for all tests were found to be extremely small, that is less than 0.0001, and so it means that my test was carried out with an alpha of 1%, indicating a stronger evidence against the null hypothesis of a perfect fit. So additionally, the presence of ties and the observations that only 247 out of 248 values were unique provided important insight in the nature of the data. So in conclusion, the high value in the data significantly diverged from the assumed theoretical distribution, suggesting potential differences or anomalies underlying data generating the process. So it means the open and high were indeed not having the same what? The same distribution model, the same all their distributions different. So yes, in case you have any question, you can ask now. So that's what we were supposed to cover today. So tomorrow we will be doing data visualizations, and it will be very nice topic. You will understand the syntax of visualizing data using commands in this software. So do you have any question up to that point before we call it a day? Any question? Frida, go through the notes keenly, please. Usilipia the program and you end up, and at the end of the program unarudi the way you were. Sindio? Sindio, Frida?
Sure.
Yeah. So at least ukuwe na difference, yeah.
Mm.
Yeah. Priscilla, do you have anything to say?
No, I have nothing to add.
Okay, I think yes, Mr. Joseph, do you have anything?
No, at least today I've learned something a bit.
Oh yeah, very good, very
Mm.
good. Yeah. So
I've remembered the non-parametric test.
yeah, yeah, yeah. Okay, actually, let me tell you,
Uh-huh.
when I learned the non-parametric methods in my fourth year course, nilikuwa nauliza hizi makruskawalizi, where will I nitazitumia
Itatusaidia
wapi,
wapi?
itatusaidia wapi, unaona? But
Sure.
now, unakuta when I'm doing research, because most of my time I write research papers, utakuta most
Mhm,
of the time some data tend not to follow a specific distribution. Unapata?
mhm,
So na
mhm.
shift tu na ni parametric methods. Nakuta sasa zile makurusi kawalisi huko. Unapata? And I use them to do my conclusions.
Eh,
Yes, that's how
okay,
learning
they
process
are very
is.
useful. I used to ignore them in campus, but now
So utazikumbuka tu.
naziona, I'll remember them.
Yeah, yeah, yeah.
Nazikumbuka kabisa. And I know they will assist me somewhere.
Yeah, they will assist you some. For example,
Mhm,
last week I was doing a research for a farm in Rwanda. For a farm in Rwanda. So these
mhm,
fellas walikuwa wanataka kutumia regression analysis, but their data haikuwa normally distributed. So what do we do? Tukashift kwa nani
mhm,
parametric methods. Venye nilipresent hiyo kitu, huyo director wa hiyo nini alikuwa ananiambia bwana, hujatumia regression analysis. Nikamwambia
mhm,
wakasema, so we have our doctor who
mhm,
is in charge of analytics team. Let's consult
mhm,
him. Nikamwambia very okay, you can go and consult him or her.
mhm,
Hey, tulikuwa na meeting usiku on day before yesterday, yeah.
mhm.
Huyo doctor alikuwa ananiuliza do you have PhD in statistics? Nikamwambia no, I just have the knowledge. And the things were okay. Vitu
They
zilienda.
were okay.
Yes.
Okay,
Yeah.
it's
So
something good.